Hi students, today we are learning the topic is diagonalizable matrix. That is a given square matrix, how to convert it to the diagonal matrix. Okay, see the first of all definition. A matrix A is said to be diagonalizable if it is similar to a diagonal matrix by similar transformation, and that means given matrix is reducible to diagonal matrix. That means similar means that matrix A and diagonal matrix having the same eigenvalues. So how to convert the given matrix by using the transformation. And also another definition is, so A is the any square matrix of order n and there exists a non-singular square matrix P, same order, such that P inverse AP అంటే P one of the matrix inverse find out చేసి into given matrix into P matrix. So multiplying the three matrices we getting the one of the matrix. That matrix is the diagonal matrix. So that diagonal matrix and given square matrix A both are similar. Similar means that matrix given matrix have the same eigenvalues. So this is a given matrix A is called a diagonal matrix. So how to convert? What is the given matrix P? So P is the columns whose columns are linearly independent eigenvectors corresponding to eigenvalues of A. Then A is called diagonal. This procedure is called diagonalization. So how to finding P is one of the given procedure. In the procedure we have to finding. Okay na? And here, so the matrix D is the diagonal matrix here. That matrix is called a spectral matrix. And here P matrix is called a modal matrix. Okay. And the diagonal matrix ఎలా ఉంటే diagonal means must be equal to the eigenvalues of A and D. So then A is called diagonalizable. So some important notes here. First one, a square matrix of order n is diagonalizable if and only if it possesses n linearly independent eigenvectors. So given matrix diagonalizable అయింది అనుకోండి is always order ఎంత ఉంటే that is the number of order there exist linearly independent eigenvectors exist. If the eigenvalues of the matrix A of order n all distinct, then it is always similar to diagonal matrix. In case eigenvalues of A all are distinct eigenvalues, it is always diagonalizable. So next one, if the eigenvalues of the matrix A of order n, so if the eigenvalues of the matrix A of order n are not distinct, if the algebraic multiplicity am and geometric multiplicity gm of each eigenvalue of A are same, then the matrix A is diagonalizable, that is similar to diagonal matrix. In case the given eigenvalues are not distinct, and next verify the condition is for each eigenvalue of am is equal to gm. Already we are discussing the previous lecture. Am is the algebraic multiplicity and the geometric multiplicity must be equal for each eigenvalues only. In case at least one eigenvalue is not satisfy that condition, then that matrix is not diagonalizable. So every eigenvalue the condition must be satisfied. Okay. If A is similar to diagonal matrix D, the diagonal elements of D are the eigenvalues of A. Already I told. A is converted to diagonal matrix D. D and A having the same eigenvalues. Okay, this is important notes. So working rule. Okay, see the working rule for diagonalization of a square matrix. So step 1, first of all finding the eigenvalues of the square matrix A and find the eigenvectors corresponding to each eigenvalue and check the condition am and is equal to gm for each eigen. Okay, check the condition am is equal to gm for each eigenvalue of A. Next step 4, find the modal matrix having the eigenvectors as its column vectors. So next finding the diagonal matrix D is equal to P inverse AP. So next finding, after finding P, next product to 3 matrices, next finding P inverse find out char. P inverse A into P, we getting the diagonal matrix. So the diagonal matrix, the diagonal elements are eigenvalues of given matrix. Okay, this is a working rule. Okay, see the example here. Show that the given matrix is similar to diagonal matrix. Find the diagonal and modal matrices. Okay, so there is a given matrix A. First of all, finding the eigenvalues. So there is a characteristic equation lambda cube minus s1 into lambda square plus s2 into lambda minus s3 is equal 0. Okay, s1 is equal to trace of the matrix. 8 plus 7 plus 3 is equal to 18. The same procedure already we discussed in the previous lecture. S2 is equal sum of minus of principal diagonal elements of A. Okay, that is equal finding the sum of the minors. This is all. Okay. Next one, S2 is equal 45. Next, S3 is equal to dta. Dta is equal, we getting 0. Okay. So substituting S1, S2 in the equation 1, that is equal to lambda cube minus 18 lambda square plus 45 minus 0 is equal to 0. So finding the factorization, lambda into lambda minus 3 into lambda minus 15 is equal to 0. So eigenvalues, that is characteristic roots are 0, 3, 15. Okay, na? So this is eigenvalues distinct. So now finding eigenvectors corresponding each eigenvalues. Okay. Next one, assumption algebraic multiplicity. So algebraic multiplicity of first eigenvalue 0 is 1 and how many time repeated? 1 time 0. So second eigenvalue 3. Algebraic multiplicity of 3 is 1 time repeat. Next algebraic multiplicity of 15 is 1. So all are repeated 1 time. This is a algebraic multiplicity and eigenvalues. So next continuation of finding eigenvectors. So let x be the eigenvector corresponding to eigenvalue lambda. Then the matrix equation a minus lambda into x is equal to 0 same procedure. First lambda is equal to 0, that is equal to ax is equal to 0 that is equal to, this is the a into x is equal to 0 So same, this element 0, this element 0, same procedure, row echelon form converted. So R2 is equal to 8R2 plus 6R1. R3 tends to 4R3 minus R1. Okay. So that is equal to 0, 0. Next one, this element 0. Using R2. 2R3 plus 2R2. That is equal to 0. So that is equal to dividing by R2, R1 by 2, R2 by 20 for simplification. Okay, that is equal to, so row echelon form andi. Rank is 2, number of unknowns 3. So that is 2 less than 3 infinite many solutions. So number of arbitrary values, that is GM. So GM means geometric multiplicity, that means number of arbitrary values of the given eigenvalues. So that is equal in the 3 minus 2 is equal 1. So algebraic multiplicity of lambda is equal 0, 1. Ikkada geometric multiplicity also 1 both are equal. So for first eigenvalues ki condition equivalent, AM is equal to GM. Okay, next corresponding equation. So 4x minus 3y plus z is equal to 0. Next to 5y minus z is equal to 0. So any y or z is a arbitrary value. So z is equal to k1. K1 is non-zero real number. Next y is equal to here. Y is equal to k1. Okay. So next one, substituting y, z, we are getting x value. That is 4x minus 3k1 plus k1 is equal to 0. X is equal to 1 by 2 k1. So eigenvector x1 is equal to here 1 by 2 k1, k1, k1. So for choosing only simplification, we have to common 1 by 2 k1 common. So that is 1 by 2 k1 common 1 2 2. So this is the first linearly independent eigenvector 1 2 2 anamata. And 1 by 2 k1 the removed is not required. Okay, this is the first one. Similarly, we have to finding the second eigenvector. So that is equal to lambda is equal 3. That is equal to a minus 3i into x is equal to 0. Okay, same procedure. That is matrix A lo only diagonal elements minus 3 char. That is equal to, okay. Simplification here. Next this element 0, this element 0. By using 5r2 plus 6r1. Next to 5r3 minus 2r1. That is equal to these two element zeros. Next one, this element 0 minus 8. So 2r3 minus r2. That is equal to simplification. So that is equal to r2 by minus 8 chesinandi for simplification. So that is equal to 5 minus 6 2 0 2 1 0 0 0. So rank is 2, number of unknowns 3. So therefore geometric multiplicity of eigenvalue, that is number of arbitrary values, number of independent vectors. So 3 minus 2 is equal 1. So geometric multiplicity of eigenvalue lambda is equal 3 is 1 kada. Ikkada am is equal 1, gm is equal 1. So equal. So condition also satisfied here. Next corresponding equation. So 5x minus 6y plus 2z is equal to 0. Second equation 2y plus z is equal to 0. Okay. So assumption any variable is independent. Z is equal to k2 assumption. K2 is a non-zero real number. Substituting here 2y plus k2 is equal to 0. So y is equal to minus 1 by 2 k2. Next substituting x value finding. So x is equal to substituting yz, we getting x is equal to minus k2. Therefore second eigenvector, so minus k2 minus 1 by 2 k2 k2 kada. So minus 1 by 2 k2 common here. Remaining here linearly independent eigenvector 2 1 minus 2. This is a linearly independent eigenvector 2 for eigenvalue 3. Okay, this is the second one. Similarly, we have to finding third eigenvector. So if lambda is equal to 15, so that is equal to a minus 15i into x is equal to 0. That is equal to, this is a minus 15i. So that is equal to, so next one, this element 0, this element 0. Using R1, 7R2 minus 6R1, 7R3 plus 2R1. So that is equal to this element 2 zeros. Next to this element 0. Okay, using R2. That is equal to R3 minus 2R2. Yes, okay. This is a 0. Next here simplification. R2 by minus 20 chain for simplification. So minus 7 minus 6 2 0 1 2 0 0 0. So this is a row echelon form. Rank is 2. Number of unknowns 3. So number of arbitrary values, that is number of linearly independent eigenvectors. So that is equal geometric multiplicity n minus r kada. That is 3 minus 2 is equal 1. Gm is equal to, we know that am algebraic multiplicity of eigenvalue lambda is equal 15 is 1 kada. Ikkada am is equal 1, ikkada gm is equal 1. So therefore equal. So am is equal to gm. Chudandi. For each eigenvalue the condition am is equal to gm satisfied. So given matrix is diagonalizable. So now finding the diagonal matrix. Okay na? So same third eigenvectors find out cheyandi. Corresponding equation minus 7x minus 6y plus 2z is equal to 0. Second equation y plus 2z is equal to 0. So assumption any one is independent, that is z is equal to k3. So y plus 2k3 is equal to y is equal to minus 2k3. Substituting yz, so x is equal to here getting 2k3. Therefore third eigenvector 2k3 minus 2k3 k3. So k3 common 2 minus 2 1. So this is the third linearly independent eigenvectors. So 3 eigenvectors completed. Next write down modal matrix kada. So this is a 3 linearly independent eigenvectors corresponding to 0, 3, 15. So next, modal matrix. What is a modal matrix? Each column eigenvector. First column first eigenvector, second column second eigenvector, third column third eigenvector. చూడండి ఇది x1 first vector, second vector, third vector. చూడండి first column, second column, third column. So next, finding P inverse. Okay na? First finding the coefficient matrix. So determine, find out చేయండి ఇక్కడ mod P minus 27 అంటే P ఇన్వర్స్ ఎలా ఫైండ్ అవుట్ చేస్తాం మనం? ఫార్ములా ఉంటుంది మనకి, అడ్జాయింట్ A బై డెట్ A కదా. అంటే ఇక్కడ ఫైండింగ్ P ఇన్వర్స్ ఈజ్ ఈక్వల్ టు అడ్జాయింట్ P బై డెట్ P ఫైండ్ అవుట్. సో హౌ టు ఫైండింగ్ అడ్జాయింట్ P? ఫస్ట్ ఆఫ్ ఆల్ ఫైండింగ్ కోఫాక్టర్ మ్యాట్రిక్స్. అంటే ఫర్ ఈచ్ ఎలిమెంట్కి కోఫాక్టర్ ఫైండ్ అవుట్ చేయాలి. అంటే మైనర్ ఫైండ్ అవుట్ చేస్తే కోఫాక్టర్. సో నెక్స్ట్ కోఫాక్టర్ మ్యాట్రిక్స్ తర్వాత ట్రాన్స్పోజ్ ఆఫ్ ది కోఫాక్టర్ మ్యాట్రిక్స్, దట్ ఈజ్ ఈక్వల్ టు అడ్జాయింట్ ఆఫ్ P. ఓకేనా? యా, ఫస్ట్ ఫైండింగ్ cofactor matrix. So this is a cofactor matrix అంటే ఫర్ ఈచ్ ఎలిమెంట్కి మైనర్ ఫైండ్ అవుట్ చేయాలి. మైనర్ విత్ -1/i+j తో మల్టిప్లై చేయాలి ఈచ్ ఎలిమెంట్కి. ఇక్కడ ప్లస్ మైనస్ ప్లస్ మైనస్ ప్లస్ మైనస్ ప్లస్ మైనస్ అని కదా. సో దిస్ ఈజ్ అ ఫైండింగ్ కోఫాక్టర్ మ్యాట్రిక్స్. నెక్స్ట్, అడ్జాయింట్ ఆఫ్ P ఈజ్ ఈక్వల్ టు ట్రాన్స్పోజ్ ఆఫ్ ది మ్యాట్రిక్స్. ఈ కోఫాక్టర్కి ట్రాన్స్పోజ్ చేయాలి. ఓకేనా? దిస్ ఈజ్ అ ట్రాన్స్పోజ్ మ్యాట్రిక్స్, అడ్జాయింట్ ఆఫ్ మ్యాట్రిక్స్. దట్ ఈస్ అర్జెంట్ P ఈజ్ ఈక్వల్ టు ఇక్కడ -3 కామన్ తీసిందండి. ఓకేనా? మనం నేర్చుకున్నాం కదా కోఫాక్టర్ ఫైండ్ అవుట్ చేయడం, అర్జెంట్ P, అది సేమ్ ప్రొసీజర్, అది ఫైండ్ అవుట్ చేసుకోవాలి. ఓకే, దిస్ ఈజ్ అర్జెంట్ ఆఫ్ P. నెక్స్ట్, ఫైండింగ్ P ఇన్వర్స్. ఓకేనా? సో P ఇన్వర్స్ ఈజ్ ఈక్వల్ టు అర్జెంట్ P బై డెట్ P. సో దిస్ ఈజ్ అర్జెంట్ P బై డెట్. So now finding P inverse AP. Okay na? P inverse into A into P find out shall. That is equal P inverse A into P. This is a P inverse. This is the A. This is a P. So 3 matrices multiplying. We getting the matrix is. So this is after multiplication. So that is equal to after 2 matrices multiplication. The simplification do simplification, again multiply these 2 matrices. Okay, that is equal to, after simplification, so after multiplying the 2 matrices, again simplification is 1/9 into 0 0 0 0 27 0 0 0 135. So now dividing by 9 to each element. So 0 0 0 0 3 0 0 0 15. So observe cheyandi, this is a diagonal matrix. చూడండి, what is the diagonal elements? 0 3 15. 0 3 15 eigenvalues కదా. So given matrix A is a diagonalizable, therefore diagonal matrix is this one, D. So P inverse AP is equal to, this is a diagonal matrix, is also called a spectral matrix. So the diagonal elements of D are the eigenvalues of the given matrix A. This is the procedure of diagonal matrix. Okay na? Okay, see the next example. Hence the given matrix A is a diagonalizable. Yeah. Second example, test for diagonalizable the matrix. The same procedure and okay na? This is a given matrix assumption. A is equal given matrix. Now finding the eigenvalues. First choosing characteristic equation. This is a characteristic equation. Finding S1, S2, S3. S1 is equal trace of A 5. S2 is equal sum of minus of diagonal elements of A. That is equal to getting the value 8. Okay. Next, S3, det of A. Det of A finding 4. Substituting S1, S2, S3 in the equation 1. From equation 1, lambda cube minus 5 lambda square plus 8 lambda minus 4 is equal to 0. So factorization, lambda minus 1 into lambda square minus 4 lambda plus 4 is equal to 0. Again factorization, lambda minus 1 into lambda minus 2 into lambda minus 2 is equal to 0. So lambda is equal to eigenvalues are 2 to 1. So next algebraic multiplicity finding. Am of first eigenvalue 2 is 2. And eigenvalue 2 is repeated 2 times together. So Am of eigenvalue 2 is 2. Next eigenvalue 1. So Am of lambda is equal 1 is 1. 1 is eigenvalue repeated 1 time. That is Am is equal to 1. So this is the eigenvalues. Next finding eigenvectors. Okay. So let the eigenmatrix A minus lambda I into x is equal to 0. First eigenvalue if lambda is equal to 2. So that is A minus lambda I into x is equal to 0. Lambda is equal to substitute. A minus 2i into x is equal to 0. So substituting in the matrix A only diagonal elements minus 2 change. Okay na? After simplification this one. Okay na? Next which is convert to row echelon form. So this is element will be 0. R3 minus R1. So minus 1, 2, 2, 0, 0, 1, 0, 0, minus 2. Next one, maybe this element will be 0 using R2. R3 minus 2 R2. That is equal to minus 1, 2, 2, 0, 0, 1, 0, 0, 0. Substituting this row echelon form. Rank is 2. Number of unknowns 3. Next finding geometric multiplicity. So geometric multiplicity is, so number of orbital values, that is gm n minus r gada. So 3 minus 2, number of unknowns 3 minus rank 2, 1. But algebraic multiplicity of eigenvalue 2 is 2 gada. But here geometric multiplicity is 1 వచ్చింది చూడండి. అంటే both are not equal. Am is not equal gm. Algebraic multiplicity is not equal to geometric multiplicity for eigenvalue 2. అంటే condition satisfy కాలేదు. So therefore the given matrix is not diagonalizable. Next there is no procedure. Stop the procedure. ఇక్కడికే స్టాప్ చేశారు. Because given matrix is not diagonalizable. That is equal to, but Am of lambda is equal to is 2. Am is not equal to gm for eigenvalues lambda is equal to. And for each not, for any at least for one eigenvalue is not satisfy Am is equal to gm, then the matrix is not diagonalizable. That is equal to given matrix is A is not diagonalizable. Okay now this is the diagonalizable matrices. Yeah, understood this topic, diagonalizable? Yeah, okay. Thank you. For more videos, please do subscribe my channel, like and share it. Thank you.